All right, 4.3 properties of logarithms. We have 3 properties that we're going to use. Look to use in reverse and forward and all the good stuff like that. So we have log base b of m times n. We can expand it out into 2 logs, into the addition of 2 logs, log base b of m plus log base b of n. So that's the product rule. The quotient rule is if we have log base b of m divided by n, we can expand it into the subtraction of 2 logs, log of m minus log of n. And then the power rule, if we have log base b of m to the r power, then we can take that exponent or power, bring it down front, and have r times log base b of m. So those are our 3 rules that we want to be able to condense and expand while using. Of course, give you a chance to write that down.
Professor Tucker,
All right. Yes.
I got a question. Just to get it straight in my mind, can
Mm-hmm.
I look at log? Can I look at logs as if I was looking at them as exponents
What you mean by
and
that?
treat them like exponents? Like when you have the quotient rule, you subtract.
Oh, you're talking about with that regard. Yeah, you can look at it, look at it that way. I see what you're saying. Yeah, when you're multiplying, you're adding. When you're dividing, you're subtracting.
Okay, so I can treat logs like almost like the same concepts of exponents.
Mm-hmm.
All right, thank you.
Mm-hmm. All right, so first set of directions is to expand. We want to use those 3 rules in order to expand the single log into multiple logarithms. So we have log base 4 of 35. So we can break up that log base 4 of 35 into 7 times 5. Let me get that back in there. And then use the product rule, recognizing now that I have 7 times 5, I can break that up into log base 4 of 7 plus log base 4 of 5. Don't forget to include that base 4, because remember, if you don't see anything there, then they assume there's a 10 there, and you don't want to have that as a part of your calculation. So my math lab would mark this wrong if they gave you base 4 initially. So you have to make sure base 4 is a part of your final answer in both cases. So let me put this stuff back in there.
Right. Quick question, Professor Tucker. How'd you get 7.7 times? Oh, that's 7 times 5.
Yes, sir.
I thought it said it was 7.5. Sorry.
Yeah. No, you're fine. All right, so let's look at this next one. So notice the next one and how I broke that one up. We have log of 10 times x. And so there's nothing there for the base. So they assume that if you don't see anything, then there is a 10 there for the base. That's what I was mentioning in the last expression, last example. So I broke it up into log of 10 times log of x. So it'd be log of 10 plus log of x. Instead of breaking up that 10 into 2 times 5, I broke it up into 10 times x. And the reason why you do that is because that common base of 10 is there, and that can simplify to just 1. So you always want to write your simplest expression possible. So once again, I didn't break up that 10 into 2 times 5 because I wanted to be able to do this. Looking at what we had here, there was nowhere else we could go but 7 times 5. So that's why we did that. Next one, log base 7 of 19 over x. So 19 divided by x, we should be subtracting. So that's what we did there. Neither one of those could be broken down any further. 19 is prime and x is just x. So log base 7 of 19 minus log base 7 of x is all we could do there. All right. Looking at this next one, D. You have the natural log of e to the third power over 7. So first thing we recognize is that that suggests that we should use the quotient rule. So we'll subtract those. And our base for the natural log is e. So that relationship allows us to cancel this part out and leave us with just the 3. So that's why we have 3 minus the natural log of 7. All right, questions? Any questions? All right, next one. We have log base 5 of 7 to the 4th power. And since we have a power, all they want you to do is use the product rule. I mean, not product rule, but the power rule. Take the 4, put it out front. So that's 4 log base 5 of 7. So that's all they wanted you to do there.
Professor Tucker,
Mm-hmm.
could you like just one more time explain C and D to me? The log base of 7, 19 over x,
Mm-hmm.
and
So now with C, we didn't do anything but apply the quotient rule. Oh, because it was division, that means you use subtraction.
you subtract, okay?
Right. And we did the same thing with D. It's just that we had this extra step that the natural log of e to the 3rd power
It got
cancels out.
canceled
Right, and just
because
leaves
there's
us with
E
it.
right there.
Right, exactly.
And for the third, the rule of power, it's just you move the 4 to the front.
Mm-hmm.
And is it going to be always like that, or are we
Mm-hmm.
going to?
Yep, that'll
Always
always
be
be
like
the case. That'll always be the case. That's your power rule. Yep. All right. All right. Next one. Let me erase this. So here we have natural log of the square root of x. So over here on the right, this was just a classmate had asked, well, a classmate of a student in a previous class had asked, where I got this part right here. I have x to the 1/2 power. So just reemphasizing the square root is the same thing as x to the 1/2. Cube root, same thing as a power 1/3. Fourth root, same thing as power 1/4, and so on. So fifth root, same thing. If you had the 100th root, that would be x to the 1 over 100th power. So this square root is the exponent of 1/2. And so then you take the square root or that 1/2 out front. And it's just a power rule. But the first thing you need to do, even if you didn't write it down, you recognize that the square root is the 1/2 power. So that's where that came from. All right. Make sure we're good before we go to the next thing. All right. So next thing we want to do, we want to expand again, but they're giving us multiple steps to do so. So let's look at this one. Erase some stuff. All right. So here we have log base a of x squared times square root of y. So now because we have the multiplication in here, that means we're going to add our logs. So remember, multiplication is addition. Division is subtraction. So once we expand our logs, we have this expression, log base a of x squared plus log base a of the square root of y. And then we take our exponents to the front, and that would be 2 log base a of x plus 1/2 log base a of y. Any problems with that one before we go to the next one? All right. So now here, log base 6 of the cube root of x over 36 y to the 4th. So that's going to be subtraction. Where's this stuff? Oh, hit the wrong button. Sorry about that, guys. Hit the wrong button. All right, so that will give us log base 6 of the cube root of x minus log base 6 of 36 y to the 4th. So that's the first step. We break them up according to the quotient rule. Now that denominator can be broken up further. We have 36 times y to the 4th right here. So we can break that up. But it's important to recognize that whatever comes out of the denominator is going to have a minus sign in front of it. In other words, both of those came from this minus log. So once I expand it out, both of them should still have a minus sign in front of it. So that's why I put the parentheses there, just to signify that both of those terms come from the subtraction of that log. Okay? And so that's why we're looking at now this expression, which is log base 6 of x to the 1/3 minus log base 6 of 36 minus log base 6 of y to the 4th. So once again, both of these terms were in the denominator. Both of them, once you fully expand it out, have the minus sign sitting in front of them. All right, so make sure we're okay before we go to the next step. All right, so now also when we look at why it was important that we break up the 36 and the y to the 4th is because we have a base of 6 for our log, and 36 can be written in terms of 6 by rewriting it as 6 squared. So that's what I do here. Let me erase this. So we have log base 6 of x to the 1/3, log base 6 of 6 squared minus log base 6 of y to the 4th. All right, so now we simplify. So we take our bases, bring them out front, and then this log base 6 of 6 squared will reduce to just the 2. And we have our final expression, 1/3 log base 6 of x minus 2 minus 4 log base 6 of y.
I have a question, Mr. Tucker.
Yep.
We will, like, it will tell us, like, use the product rule or the coding rule or the power rule.
No, it would just say expand.
Expand.
So And so you will have to lean on the clues that you see that will dictate whether it's a product, quotient, or the power rule. So in other
And that
words,
will like it's how it's written, right? Like the product rule is always written log b times it's multiplication. The next one is division, and the third one is where it's some power to something.
right. Hmm.
So is that the clue that we're looking for? How
Yes,
it's written?
yes, yes. So, here we
Like
have
these
multiplication.
first couple of rules here. First three rules will tell us.
Hmm. Yep. So, yeah, they're the only three rules you're using.
Gotcha.
And you got the multiplication. Then here you have division, which is the quotient. And then, the power rule just implemented, throughout. Let me see. I saw somebody in the chat. Oh, no, what happened to my stuff? Okay, there we go. Hit the wrong button. All right, let me see what somebody said in the chat. Yes, the sixes cancel out. Whereas the log base 6 of 6 that cancels, and that leaves you with just the exponent. So whenever you have that relationship, if you have log base x of x to the 5th power, that's going to cancel out and just leave you with 5. So that relationship right there cancels and leave you with just the exponent. All right, hopefully that answered your question. All right.
Professor Tucker.
Yes, sir.
This is 4.2.
4.3.
Okay, okay.
Mm-hmm.
Because in the corner I was like 4.2. I thought we finished that last class.
Yeah, this 4.3. Yeah, it's 4.2. This is the start of my 4.2, and then I rolled into 4.3, and I just never put that in my notes. Yeah. So
Okay.
like if you go here, see, 4.2 is up here, and then I just kept rolling with 4.3.
Okay.
Yeah. So you're good to go. All right. So the next one, we want to go in the opposite direction. We want to condense our logs. So if you're talking about the opposite direction, if I have this log base 4 of 2 plus log base 4 of 32 to go in the opposite direction and make it a single log, I would multiply those. And that's why I have 2 times 32. So we just reversing the process that we used previously. 2 times 32 is 64. Now, if I can write this 64 in terms of 4, then I would look to do so that I can reduce it all the way down. And 64 can be rewritten as 4 to the 3rd power. And then just like with those 6s, as your classmate asked, these 4s and this log base 4 will cancel, leave you with just a 3. All right, questions before we look at the next one? All right.
Is this the last test we have before the final exam?
Yes, yes. And I haven't decided because we got a lot of time. Yeah, if we do make this the final, see, what I'm trying to decide is if this is going to be the actual final or if this is going to be a final test. I'm still debating because we have a lot of time. So I'm just trying to figure out stuff. But yeah, chapter 4, there would not be another set of content, put it like that, that will produce another test. So most definitely that would not be the case.
Yes, sir. All right, thank you.
Mm-hmm. All right, so here we have 2 log of 4x minus 3 minus log of x. So the first thing you want to do is get rid of the number that's sitting out front by taking it back to being an exponent. Use the the power rule. And then since we have subtraction, go ahead and write it. Yep, of course I still have my eraser on. But go ahead and write it as division. And that would be your answer. All right, questions. Everybody good before I scroll up to see, make sure we're good. All right, so C, let me erase this. So we have 4 log base A of X minus 2 log base A of 7 minus 1/2 log base A of Y. All right, so first thing you want to do is take your exponents, take your coefficients, really is what they are right now, and turn them back into exponents. So so what we have is log base A of X to the 4th minus log base A of 7 squared minus log base A of Y to the 1/2. All right, so now next step is to recognize that we have 2 minus signs. You remember what I talked about last time when we were expanding. If you have a minus sign sitting in front of your log, that actually signifies that those are the terms that will be in your denominator ultimately. So I will combine these two. 7 squared is 49. And then we have y to the 1/2 and make this single log. So that's log base A x to the 4th minus log base A 49 y to the 1/2. All right, so make sure we're okay with that. All right, and now that we have subtraction, we can just go ahead and write it as division. So it'll be x to the 4th over 49 y to the 1/2, or you can write it as 49 square root of y. So either or is fine. All right, questions.
How would you have us write it in my math lab? Which one?
Either one of them is fine.
Either one is fine?
Mm-hmm. Yep. Either one of them should work as long as you type it in correctly. Yep.
Okay.
All right. Everybody all right before we go to the next thing?
Professor Tucker,
Yes, sir.
I ain't gonna get it until I watch it like several times.
Gotcha, sir.
It's got real.
All right. So last thing out of this section, change of base theorem or change of base property. Says if you have the log base b of m, then that will be equal to log of m over log of b, or natural log of m over natural log of b. So the reason why they give you this as an option, or let you know that this is an option, because remember I mentioned before that most calculators will have the common log and the natural log guaranteed, but there's no guarantee that you will have the option like this right here, where you can change the base of your log and put in any base that you would like. So the only options that you have is the common log or the natural log in your calculator. That's when the change of base theorem comes into play. So if you decide to use the common log, just remember that your base goes down here and this number is on top in the numerator. And the same thing with the natural log, your base goes down bottom and the number that was being applied by the log goes up top, and you'll get the same answer. So if I have log base 5 of 140, and I want to figure out what that answer is, I will use, or I could use, the common log. And if I do that, that's going to be log of 140 over the log of 5. So log of 140 is 2.14613. Log of 5 is 0.69897. Divide that out, and that gives me 3.07.
Wait. How did you get 2.414613? Oh, the calculator. Wait. Let me do it. I gotta do it. So
Yes,
you hit
sir.
log first, or you hit like 140 first?
It depends on the type of calculator you have. If it's just a calculator that has the screen up, yeah, you can do log, should be able to do log 140. That calculator may actually have this right here, this option. So you can look for
Yeah.
that as well. Because if you have that option, you don't have to use the change of base theorem.
No, it doesn't have. Oh, it actually does have that. The button that you showed, log.
Mm-hmm.
Yeah. So how do I use that? I just hit it and do what?
So you should be able to hit that log and then type in the number for
5
the box and type
and
in the
then
number for
140.
yeah.
It gives me 3 point something.
Yep.
Oh, yeah. It gives me the entire answer.
Mm-hmm.
I
Yep.
see.
Yeah. And then my math lab will let you know how many decimal places they want you to go, of course.
I recommend buying this because this thing was only like 10, 15 bucks.
Oh, that's cool. That's cool.
It's cheap. It's in Walmart, guys. Go buy it. Who are you going to like PreCalc 2?
Hey, you make me mad, dude. You got a free book and a cheap calculator, and I paid full price.
Hey, I don't know how I got it. I just got lucky. Okay, let's just leave it at that. And nobody complains about it. I got it.
I'm hanging, bro.
I don't want
hanging.
anybody complaining about my free stuff. I like it.
All right. Well, let's go ahead and finish it off. We got the natural log. If you decide to use natural log instead of common log, then you can do the natural log of 140 over the natural log of 5. Now you'll start off, you initially get two different numbers, but you'll still get the 3.07 once you're finished. Okay, cool. Yeah, if you can find out a way without, without spending that money, that's always a good look. Um, you know, I'm not in the business of trying to make you guys spend extra money.
I already spent the money.
I'm sorry, sir, for your loss. But any questions on the change of base theorem? Any questions? Everybody good? Everybody straight? All right, well, that is it for 4.3. Like I mentioned, there's no rush to jump into 4.4 today. I'd rather give you a chance to chew on this, and then we'll look at 4.4 next class. Any questions on anything before we leave? Make sure we're good before we leave today. All right. Okay. Well, if you guys are good, I'm good. Like I said, next class we'll do 4.4, and we'll look to use all of this stuff to solve equations. So I know you guys can't wait for that. So outside of that, you guys have a good one. Be safe, and I will see you on next class.
Hey, Professor Tucker,
Yes, sir.
I got one question, but it's dealing with chapter 3.
Okay, what you got?
C
Thank
minus
you, Tucker. Have a good one.
All right, thanks. You do the same, man.
X minus C.
Okay.
All right, and I'm using synthetic division.
Mm-hmm.
If I have a positive 6 that gives me the remainder of 0, I still have to write it as a negative 6?
Hold on now. Now you said. Now what's the original problem?
It's 18. X to the third minus 37x plus 6 equals 0.
Okay. Equal to 0. Uh-huh.
I did the 6 over 1 equals plus minus 1, plus minus 6, plus minus 3. Plus minus 3, plus minus 6 over plus minus 1. Okay. I use 6 as in my synthetic division. I get 1, 6, negative 1, 0. Then when I went to go to the equation form, I put x plus 6 in parentheses, then parentheses x to the second plus 6x minus 1.
Okay, so now hold on. Let me go back to you. So now you said when you use synthetic division, you use 6.
Yes.
Okay, so that means when you use it with your equation, it's going to be x minus 6. Because you're saying that 6 is your solution. You said that when you use 6, you end up getting 0 as your remainder, right?
Yes.
Right. So you're saying 6 is your solution. In order for 6 to be your solution, you have to have x minus 6 equal to 0. Then when you add 6 to both sides, you get x equal to 6.
That's where I get confused at. So basically, when I get that 0 answer, I take that and put that into so I get the 0 answers. You follow what I'm saying? Where I get the 0 answers.
Okay. So you're saying when you get this as your 0, that's your 0. You call a 6 your 0.
I'm trying to word it right. When I do my synthetic division, I get negative 6. Okay? Take that negative 6.
So hold on, let me ask you this. So you're saying you put negative 6 right here?
No, I'm putting a positive 6 there.
Okay.
All right? And write 1, 0 minus 37 plus 6. I bring down a 1. 6, positive 36, negative 6.
Right.
Okay. Now, where that negative 6 is, do I turn that into x minus 6?
This right here?
Yes.
That has nothing to do with anything. That's just a part of your calculation, part of your process.
All right. Then I go below and I put x plus 6.
Why are you putting x plus 6?
In parentheses, because that's the way the book showed me how to do it. Then
hold on. What are you trying to do?
Well, I'm trying to.
You're just trying to solve, right?
No, it says answer the following question about the equation below. List all the rational roots that are possible according to the rational zero theorem.
Gotcha.
Choose the correct answer below.
Okay.
Use the root from part B to solve the equation.
Right. Okay. So now you don't have to do this next. Now the book sometimes gives you extra stuff that you don't need as a part of your process. Now, if you were to use this, like I said, if that is your solution, then you're going to do x minus 6. Remember, it's always the opposite.
And this is where I get confused at. The book trips me up because do I put x? Can you write parentheses? Write that x minus 6, x. Write x minus parentheses. Do I put 6 there? You see what I'm saying? Put the 6 in parentheses.
You talking about right here?
Yeah. Do I put that in parentheses and like saying multiple?
Well, the thing about it is, if you're trying to continue to solve, you wouldn't do that. You would start here, from here, and go x squared plus 6x minus 1 equal to 0.
Yep.
Say again, you broke up.
Yep, you're right. And the book has me putting the 6 is x plus 6.
Yeah, I would. So is that a problem, an example in the book?
Yeah. Nah, this is I'm doing it from the review.
Okay, but why where are you getting the fact that they're telling you to put x plus 6?
I'm getting it out of my math lab.
So are you looking at an example?
Yeah.
Okay, let me see if I can pull that up.
You go to the review, it's number 18.
Okay, let me see. And then you clicked on help me solve the review an example.
I've been doing I have ripped out so many notebook pages. My notebook is thin.
That's called, hey man, that just means that you're doing a good job, man. You putting in that work.
Look, I put in 8 hours. Almost. I think 6.
That's almost a day's work, man. It's almost a day's work. Just wait for this thing to come back up. It kicked me out. All right, let's
I ripped out 7 pages dealing with problem 18.
Almost there. All right, so you did view an example. Okay, I'm there with you now. Hold on, let me get to the part that you are. Oh, let me share my screen so you can see what I see.
Okay. I know eventually I got to use the quadratic formula. I know that part.
Mm-hmm. So
See
now,
here? They got x plus 6.
yeah, but look in the box though. In the box, they have -6. You see what I mean? Hello?
Yeah, I'm trying to see what you mean.
Okay, hold on. All right, is it showing up now?
Yeah, I'm seeing it. I'm just trying to process it in my head what I'm supposed to see.
Okay, hold on. Let me see. You got 1, 0. Trying to look at what you did. 1, 6. 6 times 6 is 36, -1. How come your numbers are different? You got 0, -36. Oh, that's right, because you got a -6 at the back. You have a +6 at the back. So now, okay, see, now looking at yours, look at your example. You told me 18x cubed minus 37x plus 6.
No,
Huh?
it's x cubed minus 37x plus 6.
Right, that's what I said, plus 6.
Okay.
Yeah, so mine right here, you see, mine says x cubed minus 37x minus 6.
That's the example.
Right,
All right.
right. So now my question is, and what are you going off of? Are you going off of, do you have a +6 in the back or a -6 in the back?
I have a plus 6 in the back.
Now, are you looking at what you wrote, or are you looking at the example, the actual example?
I'm looking at the problem, 18.
Okay. See, my 18 is this right here. You know, x cubed minus 6x minus 4.
After you get it wrong so many times like I did, I get a new one. You get what I'm saying?
but my point is though, going off of, if you're looking at the example and comparing what you have two different problems. If yours is a +6 and the example is a -6, those are two different problems. You know what I mean?
I understand.
So that means that you can't look at, let me see, I'm trying to get there to where you were talking about. Right, see, look at this right here. It has -6 in the box, but that's why it has x plus 6 down here. But if you have a +6, if you have a +6 in that box, you're going to have x minus 6 right here. You see?
Opposite what I see.
So, yes, it's going to be the opposite, right? So yours would go x minus 6, whereas this one goes x plus 6. But it's because, you know, the opposite sign. This has a -6 in the box. Yours had a +6 in the box. So you should have x minus 6. But once again, though, you don't have to do that. That's an extra step. They're just showing you the representation. You don't even have to write that, really. That's not going to help you get your answer. You already know that this +6 is a solution. Now you take that x squared minus 6x minus 1. Let me see what you had. This right. Oh, you're writing back. Yeah, so this right here, you take this and use, like you said, the quadratic formula. And that will help you to find the answer to this. But you didn't have to rewrite it. You know, x minus 6 times x squared plus 6x minus 1. They were just showing you that that expression is the same expression that you had originally, which is this. Multiplying those two expressions together will give you this expression. So like I said, you didn't have to go here. All you had to do was just use the quadratic formula from, you know, on this part right here.
So the equation x minus c, what is that?
Oh man, I was sitting here talking and I was scribbling all on my notes.
Hmm?
Hey, you didn't even tell me. Say what?
X minus c.
X minus C. Now, what you mean by that?
You use x. I get a lot of stuff confused with the book. When you do synthetic division, it says use the formula x minus c.
Right. So the same thing with the same thing we were talking about. C just represents a number. So if I have X minus 6, that means in the box I'm going to have positive 6. Or if I had X plus 7, that means in this box I should have negative 7. You know, when I set up my synthetic division. So this represents C in the synthetic division process.
You see how it gets confusing?
Oh yeah, most definitely. Yeah, I most definitely can see how I can. Well, you know, that's why I'm not talking to you down, sir. I'm trying to help you out. I understand.
Thank you, Professor Tucker.
Yeah. I know it can get a little involved.
Yeah, I ripped out 7 pages.
Just don't rip out no hair, man. You'll be all right.
I already lost that. And turned white. But I'm thanking Professor Tucker. This one kicked my butt.
Right. I think part of the problem was that they added that step of putting that there, and it wasn't that wasn't necessary. You know, you didn't have to do that. They were just showing you that that expression represents your original expression here. That's all they were showing you.
Professor Tucker, I want you to draw something real quick.
Mm-hmm.
Draw parentheses x minus parentheses. No, not there, but the other way.
Mm-hmm.
Then put 6 there.
Then put what?
6.
Okay.
So and close the parentheses. Is that the same thing?
Mm-hmm. Yep. X minus 6.
I'm multiplying that negative to that 6.
Right.
I got too much stuff in my head. And when you're dealing with logs, it's almost dealing with rationals, right?
What do you mean exponents? That's what you were comparing it to before?
Yeah, rational exponents.
Yeah, it's like that. The principle, you know, we like I said, going back. If you're asking about the principle of division and you know correlates to subtraction, multiplication correlates to addition, then yeah, you can think about it from that standpoint. Mm-hmm.
And I'm dealing with logs, dealing with radicals.
Mm-hmm.
So I'm dealing with exponent concepts and radical concepts.
Mm-hmm.
And irrational numbers or irrational.
Let's see. Are there irrational? I mean, yeah. The log, yeah, because log of you know when you go back to let me see.
So basically, I'm pulling from the
Yeah.
concepts from MD60
Oh yeah.
and I'm trying to get it straight in my head so I know what I'm learning.
Yeah. So, you know, natural log of 140 is considered irrational. Whenever you have that run on decimal like that, that's an irrational number. So yeah. I mean, all of those concepts, everything you've done up to this point have been building blocks and building, you know, your steps going to, you know, this just like pretty much everything that we've done up to this point will be summarized kind of sort of in 4.1, because now we're going to use all of these steps to solve equations. So that's going to pull on your algebraic skills and your logarithmic and exponential relationships and, you know, all that stuff.
So basically, it just got real.
Oh, well, man, you know, don't get no realer.
Hey, I appreciate your time, Professor. I just want to make sure I'm grasping the concepts.
Yeah, not a problem at all, man. Not a problem.
You have a good day, and everybody else, y'all have a good day. The other 6 participants.
All right, man. You take care.
Yeah.
All right. Anybody else before I close? Everybody good? Everybody straight? All right. You guys take care. Have a good one. See you on Wednesday.